GitHub is much more than the place where you can store code. But let's see it in action. Meet Mona, a developer who's just been assigned a new project. Mona uses GitHub projects to manage her tasks and track iterations of work. GitHub's customizable views, filters, and layouts make it easy for teams to work their way. Mona quickly sets up an on-demand development environment using GitHub Codespaces. No more fighting with dependencies. She dives into coding with GitHub Copilot, making her code more readable and efficient. She then sets up automated testing with GitHub Actions, easily version controlled like the rest of her code. Meanwhile, Mona's colleague had set up repository rules to enforce DevOps governance practices across their GitHub organization. Mona avoids leaking secrets by using GitHub Advanced Security secret scanning push protection, and also identifies potential security vulnerabilities using code scanning. In this short video, we've seen how GitHub can streamline your experience throughout the development lifecycle.
Welcome to this Open Source Friday. As you can probably tell, I'm not in my office. It's dark behind me. I'm at a conference. Big shout out to the folks at DevOps Day in Medellin. And if you happen to be in Medellin and want to come by the GitHub booth, then come talk open source to me, please. I'm actually looking for a guest. So be my guest for the Spanish version of this stream that should hopefully come on after this. Again, I'm Andrea Griffiths, a la Colombia Dev in all places, and it's my pleasure to be here with you today for Open Source Friday. Today, we have a mega treat. We're going to be talking about something that is not only fun because it's open source, but it's fun because it's things, right? It's hardware, it's software, it's open source, it's everything. If you joined Meetup, you already know that our amazing guest today is Scott Lahteine. But I am going to give him a proper introduction. Yes, surprise, we're going to be talking about Marlin Firmware. And I don't know how many of you are interested in things, doing beyond actually just writing software, making the software that you write build stuff for you that you can hold. It's pretty epic. Marlin Firmware is one of the most popular drivers for 3D printers. And Scott has been just a key human on making sure that everything that's happening, documentation, development, and we're super fortunate to have him be a part of the open source world. So Scott has learned a lot of things, but he is a programmer. He's been programming since 1978 when he took a course on BASIC using the Apple II. How many of you can say you've done that? Fast forward years and lots of amazing development from literally everything from Amiga games, so game development, lots and lots of different interesting things. When I asked Scott a little bit ago, like how you came to be in Marlin Firmware and say I kind of fell into open source and never left, which is the story of many the maintainers. So I am going to put Scott's proper bio on the show notes, but also please take a look at this Stinky Head doc. Lucky for us, Scott fell out of web development in 2014 and while he was recovering, he began to spend more and more time customizing the Marlin firmware that runs Milli and many other 3D printers. And this is how I began. So 10 years ago, started becoming a regular contributor without further ado. And thank you so much for being up so late with me. Welcome, Scott. How are you?
I'm good, Andrea. Thank you for having me.
Thank you for being so flexible. I know that there's the chill time and it's so nice to be able to be live. But an epic treat, folks, is that even though Scott and I are right now recording live and streaming live, we will be on the chat. So if you have comments, if you have reactions, if you are interested in learning more, maybe becoming a contributor, maintainer, we need more help. Scott,
Yeah,
thank you for taking the time to join the stream today. I have to take it way back. I love to know this. So this transition into being, okay, you were tinkering, right? You can call it the tinkering.
sure.
And then suddenly you started contributing. And how did it come to be that you decided, you know what, I really like this project so much that I'm just going to try to do it. This is going to be it. This is going to be the project I contribute. Or did you contribute to other open source projects before that?
Yeah, I had been doing shareware, which was, and then of course app stores came along and I could do like App Store. But prior to that, I'd been doing like a open source driver for Wacom tablets because those had been abandoned by Wacom and they ran on serial protocols. So you'd have to get an adapter or whatever. But a lot of computers still had serial ports and stuff. So I made that and that was very popular, but it wasn't really the kind of thing that I could live off of or run
Mhm.
continually and have that be taking up all my time. It was a side thing. And for the most part, that's how it always was. It was just put things out open source and try to get help from the community to make it better. And by doing that, hopefully I get a little more help than I would otherwise. And usually I'd get a little, I definitely mostly just got requests for things that I more work for me. So when Marlin was a thing, I just ran into while trying to figure out I wanted to get more into robotics or some kind of programming away from the desktop. And I figured Arduino was a thing happening, which is these little embedded boards and they just have a little simple processor on them, and all you can really do is turn pins on and off. And what can you do with that? But apparently, that's like the heart of a lot of electronic projects. So I figured I should learn about that. And as I started exploring what I might make, I discovered one of the things that people do with that was to make 3D printers. They called them replicating rapid prototypers or RepRap machines at that time.
Right.
Yeah, patents apparently had expired, and so it was opening up suddenly that you could now actually you had the legal right to squirt plastic through a hot nozzle. Wow. Now we had robots that could do that. And I thought, gosh, if I'm going to start building stuff, electronics or whatever, the first thing I should have is one of these machines because then I can make boxes or whatever to put my stuff in. And this will be a huge learning experience. I'll figure out about stepper motors and all the components that go into 3D printing. So I just started tooling around with it and just little by little making little changes here and there. And the project was slow at that time. It was languishing a bit. That was before Chinese, like the huge boon and like Chinese 3D printers came along, like printers under $200 and stuff like was unheard of. They were
Yeah, my one.
$1,000 range. And if you could get one for 500, in a kit, that was like, wow, really cool, but you'd have to build it yourself. And probably some parts would be crappy. And so over time, the quality has gone up and the prices have gone down. Meanwhile, the choice of which firmware to use was pretty clear for me when I first encountered this technology. I was like, of all the options available, this one seems to be the most extensible and mature and like ready to go. It's also something that I could work with because it was a fairly simple C plus code style. And it was running on a very simple platform and really only targeting one or two processors. It was really simple at that time. And so in a way, it was like a nice little tinkerer project to get into. And the marriage of these two things, the electronic side and the software side, was perfect for me because coming from a software side, I was used to seeing things as loops and logic and algorithms, but electronics are like weird and what do they do? And, but there's logic in them, but there's also ways of using those electronics to drive the heater up and make it get hotter and do things with motors and all that stuff. And it was just like a whole world opened up of how to interact with all these new components. Yeah, it was a really exciting thing for me. I began digging into more and more areas of the firmware that needed a little tweak and fix and update and change and just modernization or whatever, just cleaning it up. But over time, it was like, as people were requesting things to be fixed, I found myself being like, oh, I could do that. I'll help them
Aha.
make that happen. And then there was a project that came along, a company in Austin was building a printer device or printer-like device that they wanted to run Marlin on. and they needed someone to customize that. So that's how I ended up here. During that time, I was starting to look for funding to be able to do this in a way that I could help pay developers and put out bounties and get equipment and whatever I needed to do, and actually be able to fund my rent a little bit so I could spend more of my time on this, because it was really taking up more and more time. And I think that's what happens a lot. And so for people who don't know, yeah, there's Marlin is like there's a whole stack of things. It's between
Mhm.
like, it has to deal with stepper motors, motion, it has to deal with user interface and dealing with the serial communication. And if you've got an SD card in there, it's got to know how to talk to that and then run the G code protocol, which is how we print and control machines. It's actually a common language for machine control, G code. And so that's what we adopted, a flavor of that. And so it knows how to interpret that. And yeah, it's just a massive set of different things that all come together to form one unified component that makes a machine that is really smart and can do pretty amazing things. When it comes down to it, sitting there for 2 or 3 or 4 days or a week without losing a step, making a plastic object for you is pretty amazing.
That's amazing.
Yeah.
Was 3D printing super mainstream in 2014? Was it, or was starting to
Well,
get, I guess, at the price of the machines itself when started to go down? So maybe more people
that's a
were able
funny
to
thing.
afford it.
I mean, that was the thing. It was finally coming down in price, but like all these weird models of printers were coming out at that time. And
Mhm.
everyone was just tinkering around and trying to come up with different approaches to the design. But the basics had to be there. You need something that goes in X, something that goes in Y, something that goes in Z, and then something that squirts plastic and maybe an interface to talk to it. You have a lot of flexibility beyond that. You can build them in different styles, of course. A Wild West, there were so many weird designs out there that were just like I don't know, the Ordbot, and I don't know, there were some that were just like all these big monstrosities of all metal, and these ones that were all acrylic, like if you just looked at them wrong, they would crack. And there was all kinds of just stuff coming along before everyone settled on this kind of common design you see now, which is based on the Prusa i3 or Mendel. But yeah, as far as its mainstreaming, like I was surprised how much there was going on when I started looking into it.
Really?
Wow, there's dozens of these things already, and there's all these different designs and ideas. But at that time, I remember there was a lot of stuff that was like, yeah, and you can make it at home by just drilling out a bolt and wrapping some nichrome wire around it, and that'll be your hot end. But now we've gone beyond that. We have standard components that won't burn down your entire garage now. Another big thing,
God,
safety.
do you remember the first thing that you ever worked on? Like the first actual project that you were like, okay, yeah, this is it. Whether it was the machine that you bought, you put it together yourself, or what was your first actual, I'm holding this in my hand and this came
Uh,
from the things that I was doing?
you mean in terms of this
Yeah, like
stuff?
actual, yeah.
3D printing. The first thing I wanted to do was, of course, build my own printer rather than just buy something off the
Uh-huh.
shelf or a kit. So I went way out of the way to like get all these components and probably paid way too much in shipping for them and stuff, just so I could get them all individually and get just the right motors. And I built a Prusa i3 Mendel from like a kit that was like a laser cut frame. And I had all the electronics laid out on the table to make sure everything worked. And then, of course, you cobble it all together. It was just like discovering how each thing worked with every other thing. And that initial thing was part of the process I really wanted to do. I didn't want to have it and learn it later. It was like, I wanted to know the guts.
Yeah,
So
just
that
curious
was,
to know how it did what it did.
oh yeah. And it was built badly. I built really bad. The first prints were disgusting, and I was doing like 100% infill and all this crazy stuff. And I was creating these just blobs, but eventually I did get it to the point where it was somewhat reliable. It could print, even though it was built from all these very cobbled together parts. Whatever. I learned I shouldn't cut corners and a lot about the whole process. And from that, I'm actually trying to rebuild it now. And I want to keep it in that old crufty style as much as I can, as much as there's like newer, better electronics and quieter motor drivers and all that stuff. Yeah, I just want to do that. There was that amazing moment of satisfaction when I finally did design an object that I needed to make. And then I actually had it come out and printed, and I held it in my hand for the first time. That was definitely, you can't quite describe it. It's
I
wow,
mean,
this is a thing you can actually do. It goes from
yeah.
the screen to being in your hand. And yeah, I have, of course, we all have a million of these boats that we print. This is just one of many things that you can have because you need to fix something. It's just ready to go. So I
That is,
love that whole sensation was definitely something for sure.
I love
And I
that.
hope,
Oh, we gotta take a look at things. I had to first tell a tiny little mini story because my boss, Marlin Firmware, is
Mhm.
actually a big 3D printing nerd. And
Okay,
I
cool.
remember talking to him. Every time I talk to him, it's expensive because he's getting all this stuff. And I'm like, do I need that? But
Yeah.
one of the times we were talking, a piece of my dishwasher, like the tray where you put like the glass drying thing broken off, brand new dishwasher. And I'm like, yeah,
Right.
sure, you can get a part, but it's like this obscure, like, sand something. I gotta go find them. And you could just print that. I'm like, this is the use. And I'm like,
Yeah.
I've been resisting the urge though, because I'm afraid I'll go into the deep end like too fast and too expensively
Yeah.
for me. I love to find a lab, and then actually close to me is St. Pete, there's labs where you can come in and you don't have to own the equipment. And there are people maybe not upgraded you, but that have the patience and like they actually mentor you. So you're not just like spending thousands of dollars worth of filament and just
Yeah.
creating
Yeah.
little
Cause
clubs.
yeah, there's probably a lot of waste involved, and we're trying to do what we can to reduce that. Like now, especially with multicolor printing, you may have seen
Yeah.
videos of printers that do multicolor printing, but at the end you have this pile of purging between the colors, and it's just ridiculous amounts of waste that you can't reuse unless you recycle it somehow. And we don't really have great ways to do that yet. Yeah, looking for ways to maybe have it purge it right straight out into another new filament you can just put right back in would be neat or something like that. So I'm hoping someone will come up with stuff like that because as much as this is exciting and it could revolutionize manufacturing and reduce waste in the sense of not having to ship stuff everywhere, you can just download it, print it home. There's that other side of it is just the amount of stuff that we just print to have fun and it's a hobby thing and how much
Of
of that is
course.
going to be just in landfills over the centuries. I'm troubled by that sort of stuff. So for my part, this is going to exist. So the best I can do is try to make it as least wasteful as possible, as reliable as possible, and try to avoid that kind of wastage. And so that's what we aim for with things like print recovery. If that your power goes out, being able to
Mhm.
start it back up again and things like that are just little things. They're really minor stuff. Like right now we're trying to revolutionize motion system a little bit. Revolutionize. There's a stuff
Talk
called,
to us about that. What does
yeah,
that
we could
mean?
talk about that a bit. What in terms of the motion system?
Right.
Yeah, that would be basically that everything that needs to go from to a coordinate. So we have to get from say x0 to y100 and y0 to x100, y100 or whatever. You got to accelerate at just the right rate so it doesn't just jam up and can't move. You can't just start from 0 and go immediately to 100. So a lot of little things like that come into play. And then of course the motion system also involves moving the filament as down the tube or whatever through your nozzle. And that's part of the movement. And all of that stuff comes together, coordinating them to all synchronize just right. And so a lot of that is cool. But then there's also ways that you can make the motion smoother. You can
Mhm.
reduce vibration. You can do noise canceling and all kinds of other tricks because stepper motors they're basically audible devices. They create resonances. And as you do stepping, they do a step and then they immediately stop. But all that starting and stopping creates these vibrations. And yeah, so we're learning how to cancel those with algorithms. Magic, it seems like magic because you apply this magical algorithm and suddenly like you can move faster and the print comes out smoother and you haven't done anything except apply this magic algorithm. So stuff like that has been happening now. That's some of what we're focusing on.
That is super exciting. Would you mind showing us a little bit? I don't know if you want to take us for a tour of, I definitely want to see the Marlin website, but I don't know what else you got to show us. I see a lot of stuff happening behind you. I'm like, show us things,
Oh yeah.
please.
Let's see. I can hold on. Actually, switch my cam. Hey, there's a printer. So here,
Oh, hello.
here's a typical 3D printer. This is actually a Creality CR10S that I've converted a little bit, stuck the electronics underneath and stuff, and did some other nice modifications to it. It is running Marlin firmware. Typically, we'll just turn it on, and so Marlin will be running on the printer itself. This is not
Mm.
Marlin isn't something you run on your laptop or on your computer. It just lives on the printer. And that's the only place it lives. There are some other firmwares that have multiple components that one part lives on the printer and then another part lives on a separate computer, such as a Raspberry Pi. But Marlin our theory is to try to utilize the full power of a single board. And a lot of these boards are pretty amazing and powerful boards. We have now boards like, well, they used to come at like Arduino board. And
That I'm familiar with.
you would stick a RAMPS shield on it, which stands for RepRap Arduino Mega Pololu Shield. If you can remember that, say it 10 times fast. But the basic idea is that it allows you to combine an Arduino Mega, which is a fairly slow processor, and it gives you the components so you can control 12-volt stepper motors and then heaters and connect to sensors that can detect the heat and stuff. So this is a typical RAMPS type setup with some stepper drivers stuck on it that I haven't quite wired up yet, but this is the sort of thing you would do. And then you would use a screen like this, a character display with 4 lines, and it runs a full menu. Or you could use a graphical display like the one you see here, which has its own menu of stuff. And you can control your print completely from the printer using an SD card and do your print job from there, which has always been my preference because I just could never get host printing to be reliable 100%. So I was like, I'll just stick with SD cards. But yeah, so this is typically how you would do it. And then you would calibrate, you auto home your printer, and the printer has no idea where it is until it's gone to the end stops. So it goes in the direction of the end stop switches until it hits them. And then we have a little probe that does the Z probing to check its Z position. And now it knows where it is. And from this point forward, you can control it and then you can run a print job. Typically, I might do something like a bed leveling at this point, and make sure that because the bed isn't, although it looks very flat, it's got these tiny imperfections. And so we want to detect all those and make sure that first layer goes down and stays and it adheres really well to the bed. So we'll typically heat the bed up to about 60 degrees Celsius. Heat your filament up to about 180 to 200, sometimes 220. These printers are typically set up to go up to about 260 degrees. Above that, you start to cook the Teflon, and you don't want to do that. So if you can get printers that have these all metal parts that won't cook Teflon and that are a little safer for higher temp materials. But for your average everyday consumer, if you just want to print like your typical
Tiny boat.
for tiny boats, yeah, you want to print things that don't need to be super durable. You can do this. This is a PLA material, and this is like made with cornstarch, and it's pretty inexpensive. You know, you can get rolls as inexpensive as $10 a kilogram for this stuff. And the more fancy you get, the more expensive it becomes. You can get stuff that has like an iridescent quality to it. Some of it can be really beautiful. And then, of course, there's stuff like PETG. That's a nice material that's more durable, a little higher temp, but still prints at temps that are within the range of what these printers can do. You can make a hinge that's like an active hinge, and you can bend it back and forth all day, and that plastic will never start to crack because it's that kind of plastic. It's a little more ductile, whereas PLA will start to get brittle after a while. So you get to know your materials with these things. The other way you can control this machine is with a host software, like something like an Octoprint or Octo, which is made by Gina Hauschka.
Yeah.
That's another open source project that's really popular. And I believe I have that here. Let's see. I have it open here. So you can see how this looks. So you would control here. I've got a camera that can be seen above the printer, not controlling it, but visualizing it and allowing me to have easier control. And then I can connect to the printer. I can say connect, boom. Once it's up there, and then I can do stuff like home the printer from here. And there you go. And you can see you've got total control from there. Of course, my camera view is upside down, but I can swap that. I just happened to put my camera in the wrong way, what can I say?
That's all right.
But yeah, it's really easy to just move the stuff with the controls they give you here and start a print job, pick a file from your long list of files, find the thing you're looking for. Oh yeah, I want to print my tablet stand or something. So there they are. And that's a really nice host. The other options, there are other options for firmwares. There's Clipper, and it has a similar kind of idea. You've got your firmware running on the printer, and then you've got something like this where you have a host controller that is running the print job. And with Clipper, everything runs on the host controller side pretty much. There's nothing on the printer that could run a print job if you didn't have the host controller attached to it. So it's a little more separation of powers, but it gets an equivalent experience using Octoprint.
Is that a matter of preference? Like among people who enjoy typing, that you use one or the other?
The newer tools that are built around Clipper are pretty nice looking. They have very nice
Ah,
UIs, very nice interfaces, and I like them a lot. The idea is that since those are separate components, they just need to have some kind of handshaking with whatever's running on the printer. It's potentially possible that we could have those things like mainsail and I forget the other ones, but there are these really nice interfaces for Clipper. Those could also be running in your web browser controlling a Marlin printer instead. But frankly, I find Octoprint awesome. And there are ways to dress it up and make it look nicer and do more. And of course, it has endless plugins, like anything you can imagine that you'd want to like add on to your host to visualize some data or whatever, or do some tricks. And there's a lot of tricks that that people are trying to do, make the protocols faster by having to compress the data being sent over serial and all kinds of other things. And there are a lot of just having a plugin architecture and a host system like that is one great way to push both us and the hosts to do more interesting things in that regard.
that's very cool. And shout out to Gina. I think if she is the creator of Octoprint, yeah,
Yes, she
she has
is.
started as well. Yeah,
And
brilliant.
occasionally my guru, I have to go to her and be like, hear me sage advice. How do you deal with these kinds of things in your project? And she's always helpful in guiding me in the right direction on how to approach things. So
I
yeah,
love it.
I don't think there's too many other folks who quite understand what we as open source maintainers have to do. So it's good to have other people who share the same issues and know something about them.
100%. So how many core maintainers does the Marlin project have now?
At this time, we've got probably a good dozen of us that are regularly
No.
contributing things every week. And then probably another dozen that are contributing stuff at least a few times a year. The stuff that's being contributed is amazing. Like there's an actual simulator that Marlin can run inside of that simulates a 3D printer so that we don't have to run it on a 3D printer all the time when we want to figure stuff out or just
Oh,
develop new UI elements or whatever. It actually simulates the display and simulates certain TFT displays as well. And so wow, it can do all these things. It simulates currently a Cartesian printer, but it's soon going to be working to simulate a Delta bot printer, which is cool. But yeah, that's an outside project that we've linked to, so you can actually just build it. And then we have our own separate tool, which is Auto Build Marlin, which is meant to help users to build the firmware and get it uploaded because it can be a very complicated process because of course we target so much hardware at any given time. When you need to tell the build system which hardware you're targeting because it just doesn't know automatically. So we have to provide tools that can figure that out and then tell it. So that's where that comes in. And it used to be that you would download Arduino IDE and that was the only way. And then if you wanted to target some new hardware, you would have to get new plugins for the IDE. And that was really tricky
mhm.
sometimes. Whereas now we use another outside project we rely on is Platform IO, run by Ivan Kravitz. And that's a really an amazing project for embedded developers and just anyone who wants to write stuff that targets multiple platforms because it allows you to just say, build a little bit of information together. Pretty quickly, you're targeting a whole new board or a whole new processor or whatever. And it takes all the work out of it. So that's a really nice one. So shout out to Ivan. We're definitely being pushed forward by projects like the other firmwares for sure. I talk to Kevin O'Connor of Clipper occasionally and Joe Prusha occasionally and others who are making their own firmwares and David who makes RepRap firmware. And we all share ideas and try to collaborate a little bit to make sure the standards don't get completely a million directions because we could each be just making up our own ideas of things and ignoring each other.
Yeah.
But we all get together. There's the RepRap wiki. And that's our place to put things the changes we're making, the stuff we're developing, and make sure that we don't overlap or crash into each other too badly. So some of that is really important, but we may not always have time to hang out together, but we can at least keep that information someplace in a common area and be able to share
Oh,
it.
absolutely. Absolutely. All of you are actually setting the industry standards of the way that this is done because you are the giants behind the firmware, right? That is so cool.
Yeah.
I'm glad to
I
hear
mean,
that there is collaboration there, right? Even though they're separate projects, it's nice. I didn't
mhm.
realize that y'all did that. That's really cool. That's really
Yeah,
cool.
absolutely. So those are the kind of, I didn't want to actually run a print because you have to wait for it to heat up and stuff. But I did want to give you a sense of that you do have a controller on the printer itself that gives you, in fact, this particular screen is one of the more inexpensive ones. It's just a very
Oh,
basic
really?
graphical display with a single color. But this is one of the best displays you can have on your 3D printer because you get a full menu of all the stuff that anything we develop, we always put it into the standard menu system. And then we have any screen that is written that has been made by others and they've written code for it to work with our menu system. It'll just work, which is very nice. And many have done that, which is really cool. And so this is one of the best screens to have. And then there are a few others that are more colorful that also adopt this menu system. So I highly recommend that. That's one of the main challenges actually is keeping up with all the new hardware that is
Uh-huh.
constantly coming out, among other things. Satisfying user expectations, of course, and making sure that we have good calibration routines and stuff like that is always another challenge as well.
Very cool. So if folks want to if they're already using Marlin firmware, they want to start maybe, I would love to share the ways that people can help so that how they can join the project and help the project and help you. So it's not just Scott.
Yeah. Among other things, we always need people who can give us feedback whenever they find a problem. Yeah, be sure to report any bugs you find. Check if the bug has already been reported or add your 2 cents. Me too's are fine. We just want to know that sometimes we have so much other stuff going on that we can't always get to these urgent bug reports. But when we know they're there, we'll get to them and we try to scrub as many as we can ahead of each release. So that's very important. Of course, if people do know how to contribute like code or documentation or any of those kinds of things, or just want to, like recently someone wrote a whole manual in Portuguese. So things like that are just invaluable. And anything that you can always use help with our website, which is I'm trying to build good documentation for all our configuration options, of which there are too many. I could give you a bit of a demo of how to build Marlin, but it might be too esoteric for this discussion. But in general, let's just put it this way. You have to get Visual Studio Code, and I highly recommend at that point downloading the Auto Build Marlin plugin, which will then cause it to download the other things you need. And then at that point, then you're ready to go. You can use Auto Build to build it, just go from there. But in general, yeah, it can be tricky for sure. It's got a lot of moving parts.
I'm going to share on the chat as well as on the notes themselves, how the website for sure. So folks can go and figure out the ways to contribute. I love that you mentioned the language contribution because that's like spoken natural language contribution. That's so cool.
Yep.
A bunch of folks now in Brazil just renting away like that. I love
Yep.
that. That is really cool. Of
Language
course, on the page.
translations.
Oh,
Yep.
huge.
Always good. And beyond that, let's see what else we have. If you've got a nice tuned configuration for some machine that we don't have yet,
Oh,
because that's one of the things we also maintain is a huge number of example configurations that use them to just build for a particular machine and you can go from there. So anyone who's got some for those we don't yet, bring them up, please contribute those. We can always use donations of like equipment and weird components that we haven't yet supported. We're working on things like CAN bus and I actually have CAN bus hardware. That's the kind of thing we are always looking to do is whatever we happen to be working on, trying to grab hardware for that sort of whatever is coming along. The next thing in 3D printing, we want to be able to support it, whatever it might be. And then I guess, yeah, financial donations help me to pay for bounties and to support other developers who contribute to Marlin. and to not have to do a lot of chasing of other work, which takes me away from the maintenance, which is definitely a full-time job. I have been catching up lately, and by catching up, not falling behind too badly, but it's always a bit of catch up. There's so much to do. That's the nature of the thing. This is a very fast moving industry and technology right now. Just keeping up with it. It used to be a full-time job for one person. Now it's becoming a full-time job for more. So yeah, the more that we can support, the more that we can do and keep this thing going, because even though there are new ways of having printers, like you can build them with Clipper, there's still a huge number of printers out there that can't or don't and that want to be expanded that way and that need upgrades and can still benefit from the improvements we're making, especially
Of
to
course.
things like noise canceling or input shaping in the motion system. That's like a big one. I'm hoping that everyone who has 10-year-old Ender printer will upgrade Marlin and suddenly find that it can go a lot faster and get cleaner results. I think that'd be incredible. And that's what we're aiming for, is to make it just continually better, but keep supporting all the hardware we always have. And then keep supporting as much of the new stuff that comes along as well. And keep it alive for hobbyists, because it's a great project and there's so much to learn from it. It just does so many things on so many levels.
I appreciate that. Thank you for sharing that. And yeah, keep it free, keep it open. That's important. So we need to be able to support you so that, again, as the technology advances, you're able to keep up with all of it. Definitely. For folks that want to contribute, there's many ways that you really contribute code. They can contribute with sponsorships. They can contribute with donations of the tech. And it's been 10 years since you started, and I'm sure you've seen a lot of change in this 10 years. I think you can think
Yeah.
about what's going to bring the next 10 years beyond the optimizations that you talked about, the motion. And I love the idea of having a piece of hardware that's, I don't know, 10 years old. And now by this magic algorithm, it's working way better.
Yeah.
Pretty epic. But what do you think is going to be like the future? Like, I want to do crystal ball here.
I mean, I did
What is
start
the
to joke a
future
little bit
now? I
about,
don't know what's happening.
yeah, I hinted or joked a little about AI, but they're attempting at some level to have like printers that have a camera on them, and you can tell when the print is failing by looking at the current state of using a camera and having an AI look at it and go, looks okay to me. And this is it's right now, these days, it's prone to false positives. And then it also misses things sometimes. So it's not yet perfect. But I think that in the realm of AI, that you're like have algorithms that can do amazing things, like solve, say, the best motion path for something, that could be more useful for us than the kinds of AI that are trying to like catch spaghetti. I think that we'll see a lot more AI being applied in that kind of way and less in the way that self-driving. We're going to have more of that kind of just things that are smarter and produce better results because they can solve paths faster and things like that, or figure out ways to use less plastic or do other tricks like that. And then as far as the hardware goes, like you've noticed that processors keep getting faster,
No.
and why I'm optimistic that Marlin will continue to survive and be relevant is that we have all these boards that they're just wasting their power if they only run a little thing that listens and takes commands from an external thing. And there's a very dumb controller. Since we can do so much there's so much leftover power on these boards. And so we want to utilize as much of it as we can on a single board. And if we can get the full print job plus all the motion smartness plus everything else in there, and as the boards get faster and with more memory and everything else, we can continue to do that. So that's a big part of what's coming in the future, is like just much more intelligence on board. And of course, being able to like just do things so much smarter. This motion system stuff is blowing my mind. That's like just one part of it, because we're looking at these discrete microseconds of time and making these decisions. The more microseconds that we can examine in a given moment, the better decisions we can make and the better motion we can produce. The end result is that the printer results look nicer, and hopefully in the end, we waste a lot less energy, a lot less plastic. So that's what I'm looking forward to in the future, is that we really get this stuff reliable and make it as easy to do as press a single button and go. And of course, making them really fast, because time's a wasting. And nobody wants to wait around for 3 days for a print to finish, So that's a big part of it as well. So we're definitely headed in that direction. So we can balance those. There's definitely a trade-off there. So if we can just find that balance and get them really reliable and fast, that'd be great. So that's what I'm trying to do.
Sounds like you got a lot of work ahead, Scott.
More pull requests every day.
There you
So
go. There you go. I'm hoping that some of the folks who join here today and listen, there is so much. Like I had someone on a couple of weeks ago talking about Rust and like compilers and like you think that everything is about making it faster and better. And I'm like, it's so interesting how that applies even to like hardware and like all the ways that we can improve. Like it's mind blowing, amazing,
yep.
super exciting feel. Like if someone wants to get started, what do you need to know as far as what's I guess the programming language? If I'm super into this and this is what I want to do you have any advice for folks that maybe they've been trying to find their
Uh,
niche and they watch you and they're like, I want to do that.
yeah. It's like how I found my way into this was I only looked at one small part of the code. Like, where's the part that
Right.
makes this clicky noise or whatever? And how do I change that? And then I played around with it until I found something I liked. And once I submitted a pull request. So my very first submission was a very small thing like that. And that's pretty much the best way for people who want to get into this kind of project. It's got so many little language niches that we use Python for parts of it. We use shell scripting for parts of it. We use C and C++. So people who have some knowledge of each of those areas can contribute in various ways. Little tweaks are always
Right.
fine. And in general, the main thing that we're looking for is people who really want to get their particular, they've got a machine or whatever, and they really want to get it working just right and better. And they have ideas about that. They're passionate about making that thing. They really want to get involved. The best way is just dive in and try and make that change. And we have a lot of people on the Discord helping out developers who are like willing to share, how things work. And some will rightly say, "Oh, be wary. This is very quirky code. We use a lot of
Mm.
meta programming and stuff, and there's a lot of ins and outs." But as far as any given small part, each thing is pretty straightforward. It's a very functional kind of programming style. And the C plus stuff is there more to just encapsulate things in little namespaces and organize things better more than anything else, because we want it to be low level, fast, and not waste a lot of electrons that we don't have to waste and get away with it. Those who are interested in programming and interested in the robotics side of things, because when you talk about RC cars, drones, things like that, there's ways you can get into programming of those things on your own, dog shaped robots and all that kind of stuff. And 3D printing is definitely another area where it's on a very simple level. You're dealing with a lot of the same kind of stuff. You're dealing with mechanical real world stuff and trying to mitigate that with code and logic. And if you're into that kind of thing, it's one of the best projects I've found for just combining all those levels. And of course we need documentation. So again, like that's a big one.
Oh, this is
I love,
awesome. Listen, new folks to
yeah.
come in with fresh eyes, right? And that's
hmm
all. Yeah.
Yeah.
Yeah, great.
Hopefully we're getting the pieces in place, but yeah, it's definitely,
Mhm.
most of it is slog, honestly. There's just a lot to be done.
Yeah.
So please help. Come on, put in a little time, write a few paragraphs. Every bit helps.
I love that. I'll be sure to share the Discord server as well as this is playing live so that folks can go ahead and join in. You got a massive community there. There's like over 10,000 people.
Yeah.
I took a look. It's super late where I am, and it was like 2,500 people online. I'm like, oh my gosh, things are happening from all over the world, I'm sure. So very cool. Very cool. Sounds like a really nice, supportive community to be a part of.
Oh yeah. I feel blessed, honestly, to be here and doing this. So thanks everyone.
I love it. God, this is so cool. So where can we find you? I know you're in Austin. I'm gonna share your Twitter. And so if folks go on and follow Scott, there's also a Marlin Firmware Twitter account, which also posts updates, right? So make
Yep.
sure that one too.
We're telling you about what we're working on and when the releases come out and stuff like that.
Perfect. And then are you gonna be out at like any conferences or anything else happening where folks might have a chance to meet you? I know you do
This
meetups too. Like I saw a meetup that you went with where actually Gina was there. I think it was like a recap. Yeah.
I was blessed to be able to meet Gina a couple of years ago in Sweden, and that
So
was
cool.
amazing. And Yeah, we made friends right off the bat. We're in the same boat, so we get it. So anyway, yeah, you can find me there and Twitter. There's the Marlin Firmware account. I definitely follow that. And then I also there's a YouTube presence. If you search for Thinking Head, you pretty much find me somewhere. And come to the Discord. It's a great place to hang out. And I'm trying to spend a little more time there soon as the work comes through and I feel more caught up. But yeah, come on by there. And I'd love to see everyone.
That's awesome. Scott, thank you so much again. Thank you for joining us. Thank you for inspiring folks. This is so good. There are so many ways to get involved. And I didn't realize that there were so many different components and so many other pieces that you can basically hone into anything that you care about. I love that that's how you got into it. And now to you, like, that is so cool. Very, very cool. A really fun opportunity for people who enjoy both software and hardware, and super awesome entry point for people who are interested in robotics and things like that. I didn't even consider that. So this is really cool.
That's right.
Awesome. Thank you so much for being here. Any other advice, final closing words you want to leave us with?
Just keep being creative, people, and keep sharing your stuff. And as far as there's a lot of concern about open source, and maybe folks are worried if I share my stuff, will like my company go away because everyone else will be stealing everything I do. Honestly, I think like you can't worry about that. That's your company is going to come from your style, your service, your spirit. Has so much more bearing on how you do than how others try to imitate you. They're just going to imitate you badly, and people are going to smell it. Open source has its own virtues, and those virtues have a way of spreading. Is that a very elegant final word? I don't know.
I absolutely love it. Yes. Yes, please.
Yeah.
Don't be afraid to share, because we need our collective minds. We need to keep this.
Yeah,
This is how we get better.
absolutely. And GitHub is a huge part of that. So thank you to GitHub for, especially they sent me this in
Oh,
2020.
that is the most epic thing. I love that.
What a year, 2020. That was my year of contributions in 2020.
That
And
looks
they,
like New York City
you know,
or some, yeah. Very
what
busy.
happened
Very
on
busy
what happened
timeline.
on this day? That's what I want to know. What is that?
I don't know.
But
Something broke.
it's great. We're recognizing our contributions, which is great. So thank you, GitHub, for that.
Oh, shout out. That came, Lee Riley, my team, I think, is who had that idea. Shout out to
Oh
Lee
yeah,
for that. Yeah.
that was a great idea. And I look at it and it just inspires me and reminds me every day. This is why we do it, for big, heavy metal 3D printed things.
And they also look awesome. So, hey,
It does.
it's the upline.
Beautiful thing.
So cool. Thank you, Scott. Thank you so much
Yeah.
for being here. Thank you for everyone who's joined. Click all the links. Follow Scott. Follow Marlin Firmware. If you're excited at all about all this, start doing it now. It feels like it's moving so fast, but there's always a point where we can all start and just get into it. So I thank you so much
Absolutely.
for being here. And I thank everyone who joined this transmission of pre-recorded midnight edition of Open Source Friday. See you next week.